Hey guys, welcome back. In this video we are going to talk about, or we are going to start with order and degree. So let's define order of a differential equation. So we are going to define order of differential equation. The order of highest derivative in the equation is called order of differential equation. Like if in a differential equation we have fourth derivative as the highest derivative, we will say the order of differential equation is 4. Don't worry, we are going to work on lots of example and it will be very clear to you. So the highest derivative involved in the differential equation, that order we are going to call order of differential equation. And let's define degree of differential equation. The degree of differential equation is the exponent of its highest derivative. Of highest derivative. For example, suppose we have this equation y divided by dx power 4 divided by dx cube power 3 plus y power 5 equal to x. Here the highest derivative involved is fourth derivative, right? So in this case, order of this differential equation is 4 and the exponent of its highest derivative is going to be your degree. So degree is 1. We can classify the differential equation as linear or non-linear. So let's define the linear and non-linear differential equations. So our next definition is linear differential equation. A differential equation is linear if the dependent variable and its derivative, we are not concerned about independent variable, we are just looking at dependent variable and its derivatives appears linearly. What does that mean? It means there is no exponent of the derivative or the dependent variable, they are not multiplied together. So let me just write down the meaning. So it means they appear only as first powers. So they appear linearly and they are not multiplied together. You won't see any term like y times dy over dx if it's linear differential equation. So they are not multiplied together and no other function of dependent variable appear. Like e power y, this type of function cannot appear. Sin y cannot appear if y is your dependent variable. So we have three conditions over here. First condition, they appear linearly, means only in the first power. Second condition, they are not multiplied together. Third condition, no other function of dependent variable. So this classification is based on how dependent variable appear in equation. And an equation is called non-linear if it's not linear. Okay. The journal form of a linear equation is, I already wrote it over here. Oops. Like this. So if you have a linear equation, it can always be written in the form anx dny, the nth derivative, plus the n minus 1th derivative like this. We can have any number of derivative, but the derivatives and the dependent variable are not multiplied together equal to say fx. These terms ai, these terms should depend only on x, and the dependent variable y appears only in first power. No higher power is allowed. The terms like y dy are not allowed. So this is the form of our linear equation. If we have any linear equation, we can write that equation in this form. Okay. Now if this left hand side is 0, means there is no term without the derivative multiplied to it or without the dependent variable multiplied to it, then we will say, okay, this is homogeneous equation. If this fx is non-zero, we will say that is non-homogeneous equation. So in this diagram over here, we have how linear equation look like, how non-linear equation, non-linear is if it's not linear. Homogeneous is if fx is 0, non-homogeneous is if fx is not equal to 0. Okay. So now let's go ahead and see some examples. So here is the list. We are going to figure out the order, degree, if it's the dependent variables, the independent variables, and we will classify if it's linear, non-linear, everything. Okay, let's start one by one. Here we have fourth derivative involved. So the order is 4. The degree of the highest order derivative is 1. The exponent is 1. The dependent variable is x. The independent variable is t. Since there is only one independent variable, this is ODE. This is non-linear. Let's see the next one. The highest derivative appear here is 2. So the order is 2. The exponent of highest derivative is 1. So the degree is 1. The dependent variable is y. The independent variable is x. Since there is only one independent variable, this is ODE. So first equation is non-linear because it have a function of t. A function of dependent variable, that's why it's non-linear. This equation is linear. Why? Let's check out 3 conditions. First condition is all these the dependent variable and all the derivatives have power 1, which is true in this case. Second condition is the derivatives and the dependent variable are not multiplied. They are not multiplied in this equation. Third condition is no function of dependent variable. We don't have any function of dependent variable or its derivative, so it's linear. Let's see next example. Order is 2 because the highest derivative involved is 2. So the order is 2. Its exponent is 1, so the degree is 1. Dependent variable is y, independent variable is x. There is only one independent variable, so it's ODE, ordinary differential equation. Here, a power of dependent variable is coming, so this is non-linear. Let's see next one. The highest derivative is 2. The power of highest derivative is 2, the exponent. So the degree is 2. The dependent variable is u. The independent variable is x. So this is ODE because there is only one independent variable. And this is non-linear because the power of the dependent variable is also 2 and this highest derivative power is also 2. So if the degree is more than 1, it can't be linear, so it's non-linear. So we know if degree is greater than 1, it's always non-linear. Okay. Now next. Order is 1 because only first derivative is involved. Its power is 1, so degree is 1. The dependent variable is y. The independent variable is x. Since only one independent variable, this is ODE, and since it have a function of dependent variable, this is non-linear. Next, fourth derivative is involved over here. So order is 4, its power is 5, so degree is 5, dependent variable is y, independent variable is x, also t. So this is, since we have more than one independent variable, this is PDE, and it's non-linear because degree is greater than 1, so it's non-linear. Let's check other quickly. Order is 2 because second derivative, degree is 1, exponent is 1, dependent variable is y, independent variable is x, only one independent variable, so ODE, degree, okay, linear. This equation is linear because we don't have any power of dependent or its derivative. We don't have any dependent variable or its derivative multiplied together, and we don't have any function of dependent variable, so it's linear. In this case, degree is 3, order is 3, the highest derivative is the third derivative, and its exponent is 1. So degree is 1, dependent variable is y, independent variable is x and t, two independent variables, so it's PDE. And since it have the second derivative power 2, it's non-linear. Degree is 3, the highest derivative is the third derivative, so order, I keep messing it up. The highest derivative involved is the third derivative, so order is 3, its power is 2, so degree is 2, dependent variable is y, independent variable is x, so it's ODE, and it's non-linear. These three, I leave it for you as exercise. Okay, so we know, basically we covered everything in this example. We know how to find out order, we know how to find out degree, we know how to find out if the equation is ODE or PDE or it's linear, non-linear, everything, right? Okay, let's mark homogeneous equation. So we will check the equation which are linear, and then we will mark homogeneous one. So this one, number 2, is linear and it's homogeneous. Okay, this color is not visible, let's choose something else. Along with some initial condition. Along with some appropriate number of initial conditions. Then we will call it initial value problem. Similarly, we have definition for boundary value problem, and the boundary value problem we call them as BVP, the short form, boundary value problem. So let's define those. A boundary value problem is a differential equation, I'll write DE, a differential equation together with some boundary condition, together with a set of boundary condition. So if we have a solution of boundary value problem, it means that solution will satisfy the differential equation along with the boundary condition. If we have a solution of initial value problem, the solution, the function is going to satisfy the differential equation along with those initial conditions. Let's see an example. Say dy over dx equal to d square y dx square plus 5x. This is our differential equation and some condition are given. Sorry, y. And the second example is, so this is number 1. Number 2 is equal to 16t, and at 0 the value is 2, and at 1 the value is 9. So in the first one, we are given the differential equation and the value at the initial point, 0. So this is example of initial value problem. Here we are given a differential equation and the condition on 0 and 1. The 0 and 1 are boundary values. So this is how we classify initial value problem and boundary value problem. If you have any question, feel free to ask, and I will see you in the next class, in the next video. It is the problems, how to figure out order, degree, and how to classify the equation. And in the next class, we will start with new chapter. Bye bye.